Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vector and parametric equations for line in R2. So as per the problem, a line has R equals 1 comma 2 plus S parentheses negative 2 comma 3 and S can be any real number as its vector equation. On this line, the points A, B, C and D correspond to parametric values S equals 0, 1, 2 and 3 respectively. Show that each of the following is true. So let's start with part A. In part A, we have to prove that vector AC is equal to 2 times vector AB. So the first step is to find points A, B, C and D from this given vector equation using the given parametric values. So let's start with point A. So we should sub in S as 0 in the given vector equation. Now 0 times vector negative 2 times 3 will become a 0 vector. So that term will go away. The position vector R is equal to 1 comma 2. So that means point A is 1 comma 2. Now we can find point B. For point B, we should sub in S as 1 in the given vector equation. So we should multiply the components of negative 2 comma 3 by 1. So the vector stays the same. Now we can add the vectors by adding their x and y components. So this is point B. Now we can find point C. We should sub in S as 2 in the given vector equation. So we should multiply the components in vector negative 2, 3 by 2. Now we can add the vectors. So we should add their x and y components. So this is the position vector for point C. So point C is negative 3, 8. Now we can find point D. Even though we don't need it for part A, we will need it for parts B and C. So we should sub in S as 3 in the given vector equation. So we should multiply the components of vector negative 2, 3 by 3. Now we can add the vectors. So this is the position vector for point D. So point D is negative 5, 11. Now we have to find vector AC and vector AB for part A. So let's start with vector AC. We can break up vector AC into position vectors OC and OA. We can use point C for position vector OC, and we can use point A for position vector OA. Now we can subtract the x and y components. So negative 3 minus 1 is equal to negative 4, and 8 minus 2 is 6. So this is vector AC. Now we can find vector AB. We can break it up into position vectors OB and OA. So for position vector OB, we can use point B, and we can use point A for position vector OA. We can subtract the vectors. Now we can multiply vector AB by 2. So we should multiply both components by 2. So we can see that vector AC is equal to 2 times vector AB. Therefore, the equation in part A is true. Now we can answer part B. Vector AD is equal to 3 times vector AB. Let's start by finding vector AD. We can break it up into its position vectors. We can use point D for position vector OD, and point A for position vector OA. Now we can subtract the vectors. We have already found vector AB. Now we can multiply vector AB by 3. We can multiply both components in this vector by 3. So we can see that vector AD is equal to 3 times vector AB. So we have proved that the equation in part B is true. Now we can analyze part C. Vector AC is equal to 2 over 3 times vector AD. So we found vector AC in part A, and vector AC is equal to 4, 6. And we found vector AD in part B. Now we can multiply vector AD by 2 over 3. So we multiply both components by 2 over 3, and negative 6 times 2 over 3 is equal to negative 4. And 9 times 2 over 3 is equal to 6. So we can see that vector AC is equal to 2 over 3 times vector AB. That means the equation in part C is true. So these are the steps we have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.